Now, kind of related to what's going on down here. What if forpling x doubles y instead of doubling x forples y, forpling x doubles y? Well, that kind of reverses the roles of x and y, doesn't it? And we can easily draw that. Here I've got a value of x, which I double, and then I double that to forple the original value of x. So this value forples to here, and two values of y that are equally spaced from the origin. And those values, of course, double. So forpling x doubles y, meaning if I go from here to here, the value of y could go from here to here. Now also, remember, I could continue taking 1/4 of this x value, and then 1/4 of that and 1/4 of that, approaching the origin, and half of this y value bring me down to here, half of that brings me to here, half of that brings me to here. If I continue that process, I converge on the origin, so it makes sense that the origin should be part of that graph. And I get a graph that looks something like this, which is a whole lot like what this graph looks like if I just take this graph and flip it over like so. Okay? Now, let's ask then, what does doubling x do? If forpling x doubles y, then what does doubling x do, and what's the power function ratio for this particular graph? Okay, well, if that's the case, and if y equals ax to the p, in other words, if y is a power function, and we haven't established for sure that it is, then it would turn out that 4x over x raised to the p would have to equal 2y over y. In other words, if we change x from x to 4x, then raising that to the p power would be the same as if we change y to 2y. It would give us the same result if y changed to 2y. The solution to this equation is p equals 1/2. It follows that this graph is generally of the form y equals a times x to the 1/2. And from that, without defining inverse functions, something you'll see and something we might address, probably will address, y equals x to the 1/2 is in this sense inverse to y equals x squared. Now, in terms of this graph, remember we've reversed the roles of x and y. Instead of forpling y when x doubles, we're forpling x when y doubles. So we've reversed the roles of x and y, and we get this thing called an inverse graph, and that inverse has a property that I'll write down off screen and point out. Okay, the property is, if the inverse property really means, if we do this to x, and then we do this to x, we end up with our original x. Meaning, if we square x, and then raise x to the 1/2 power, which is the same as taking the square root, then we get just our original x. Try it. Take the number 3, square it, you get 9. Take the square root of 9, what do you get? 3. Duh. Okay? X squared to the 1/2 equals x to the 2 times 1/2. There's a law of exponents that you should be very familiar with. Should be second nature to you if you've had a year of algebra. So that's x to the 1, which is just x. Okay, raise a power to a power, you multiply the powers. And there's a good reason for that, but we won't digress to that at this point. Okay, so that's kind of the characteristic of an inverse function. It's kind of important, extremely important concept in mathematics. So, little example of that in this context. I mentioned this in the context of this entire example, and which, of course, we haven't done these steps. Again, we might do them in the future. It just came up in this process because then this graph of graph slope versus y being proportional to y to the 1/2 means that if we forple the graph slope, we're doubling the value of y. Okay, the graph slope forples when the value of y doubles, and that can be seen here. If we have 4 times the slope, then it turns out that actually we have twice the value of x, which gives us twice the value of the slope. There's a connection that is worth thinking about a little bit. It's the kind of thing you have to think about to solve problems of this nature, which are actually fairly advanced, more advanced than the kind of thinking you usually do before a calculus course, the kind of thinking you should do in a calculus course, but not all calculus courses require you to think even at this level.